Today we are gonna have a discussion and a learning on surface tension and surface energy. So first of all, starting with surface tension. What is surface tension? The definition for it is surface tension is a property of a liquid at rest, by virtue of which a liquid surface gets contracted to a minimum area and behaves like a stretched membrane. So we are here that why it behaves like a stretched membrane. So we are going to discuss that. Like if we take a container and we put some liquid, let it be water, and these are the molecules of water, okay, and there is a force the force on this molecule would be like attracting force by this molecule, attracting force by this molecule, by this molecule, and by this molecule. So it is in equilibrium, that these forces cancels out, and that's why it is in equilibrium. What about the molecule at the surface? Like the only forces are attraction by these molecules, or by molecules at these sides. So net resultant would be downwards. So it should not be in equilibrium. But we in real life, we know it's in equilibrium, that while we are drinking water, that water doesn't flow out of the glass, or it doesn't move randomly, or there is no hurricane in that. but it is in equilibrium, we know that. But how? So let us discuss now that there is a sphere of influence. If there is a molecule out of the sphere of influence, there would be attractive force. But if there is then molecule inside this sphere, there would be repulsive force. Why? I'll try to elaborate. Like this is the nucleus, and this is the nucleus of other atom. This is the sphere of influence, and this is the sphere of influence. This nucleus will attract the electrons of other molecule, and this nucleus will attract the electrons of the other molecule, and this nucleus will repel this nucleus. And if these, what we call sphere of influence, if the molecule isn't inside the sphere of influence, there is the force of what we call attraction. So if the other molecule is inside the sphere of influence, there would be a repulsive force. It will try to kick that nucleus, and that applies over here. Like these are the molecules. So he is the brother of this molecule, and he wants to help him out. He is in equilibrium, and this one tries to help him. So this one will enter the sphere, and this one will also enter the sphere due to brotherhood. They are brothers of each other. So this one tries to help him out, and due to repulsion, there would be an force upward and net force upward, which will cancel this out, and this would be in equilibrium. But due to this, they were happy over here, having hydrogen bondings. I'm talking in case of water, they were having hydrogen bonding. They are happy here, but some work has to be done to make them go over there and help their brother. So that extra energy is stored in the layer, upper layer, we call that U. That U is surface energy. It is surface energy. We are talking about this surface energy. So every system wants to have minimum energy, so this increases and this increases because of surface tension, and because this molecule wants to be in equilibrium, so this has increased, and because of increase in surface, this will increase. So system will try to have the minimum energy. So they will act like a stretched membrane to decrease their surface in state of minimum energy. So they will try to decrease the surface, and the molecule over here, this will be having tendency to attract these two. They both will be attracting, but this is not allowing them to come closer, because if they'll come close, all the other will try to come on the surface, which will increase the surface energy, what the system doesn't want to. So it behaves like a stretched membrane. There is a lot of force, like this is Romeo and this is Juliet. They love very much, but this is the villain. He doesn't want them to love. So this one tries them to keep away. So the force of attraction is so much that in the case of molecules, I don't know about Romeo or Juliet, but in the case of molecules, there is very high force that even a nail or a needle will float over it because of that surface tension. Now U is proportional to A is the surface area. So U is proportional to A. U is equal to SA, where S is the surface tension. Now have a upper view of the surface like this. These are the molecules, and these are the molecules. I know my molecules are not very handsome, but all the way they are molecules, and there is a force of attraction between them. Okay, and this is the length, and there are infinite number of molecules, but I have two rows, row 1 and row 2. So there is a force, total force of attraction is F. So what is surface tension? Surface tension is force per unit length. Okay, force per unit length. Like it's like an average. You can say the force that the force between the two molecules. So both are important results, and you got to remember, they are beneficial to remember. U is equal to SA.